In a residential setting, the minimum depth for burying electrical cable from the transformer to the service panel is typically 18 inches. This depth is specified to provide adequate protection for the cable from physical damage, such as from digging, landscaping, or other activities that might occur on the property. The specific requirements can vary based on local codes and regulations, so it's crucial to consult the relevant authorities or a qualified electrician to ensure compliance with all applicable standards. The purpose of burying electrical cables at a specific depth is to safeguard against potential hazards, including electrical shock and fire. When cables are buried too close to the surface, they are more susceptible to damage from external factors, which can compromise the integrity of the insulation and expose live conductors. This can create a dangerous situation for anyone who comes into contact with the damaged cable, as well as increasing the risk of electrical fires. In addition to physical protection, burying cables at the required depth also helps to maintain a stable thermal environment for the conductors. Underground temperatures tend to be more consistent than surface temperatures, which can help to prevent overheating of the cables, especially during periods of high electrical demand. Overheating can lead to insulation breakdown and other problems, which can reduce the lifespan of the cable and increase the likelihood of electrical failures. The National Electrical Code, often abbreviated as NEC, provides guidelines for the proper installation of electrical systems, including underground wiring. While the NEC is not a law itself, it is widely adopted by local jurisdictions as the basis for their electrical codes. Therefore, it's essential to be familiar with the NEC requirements when installing underground cables. The NEC specifies different burial depths for various types of cables and wiring methods, depending on the voltage, location, and other factors. For residential services, the minimum depth for direct burial cables, such as those used to connect the transformer to the service panel, is generally 18 inches. However, there are some exceptions to this rule. For example, if the cable is installed in a rigid metal conduit or intermediate metal conduit, the minimum burial depth may be reduced to 6 inches. This is because the conduit provides additional protection for the cable, reducing the risk of damage. Another exception applies to cables that are located under a concrete slab or other permanent structure. In these cases, the minimum burial depth may be waived altogether, as the structure provides adequate protection. It's important to note that these exceptions may not apply in all jurisdictions, so it's always best to check with the local electrical inspector before proceeding with the installation. When installing underground cables, it's also crucial to follow proper grounding and bonding procedures. Grounding helps to ensure that any fault currents are safely diverted to ground, reducing the risk of electrical shock. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path for fault currents. Both grounding and bonding are essential for electrical safety and are required by the NEC. In addition to the depth requirements, there are other factors to consider when installing underground cables. For example, the cable must be properly supported and protected from damage during installation. The trench should be wide enough to accommodate the cable without stressing it, and the bottom of the trench should be free of sharp rocks or other debris that could damage the cable. The cable should also be backfilled with a suitable material, such as sand or gravel, to provide additional protection. Before digging any trench, it's essential to call the local utility companies to locate any underground utilities, such as gas lines, water pipes, and other electrical cables. Striking an underground utility line can be extremely dangerous and can result in serious injury or death. The utility companies will mark the location of their underground lines, allowing you to avoid them when digging. If you are not comfortable installing underground cables yourself, it's always best to hire a qualified electrician. A licensed electrician has the knowledge and experience to install the cable safely and in compliance with all applicable codes and regulations. They can also help you to determine the correct size and type of cable for your application, as well as providing advice on grounding, bonding, and other electrical safety issues. The correct cable size is determined by the ampacity requirements for the specific electrical load. You can determine this by adding up the total amount of amps required for the load. Using a smaller cable can cause it to overheat and could lead to a fire. Also, using too large of a cable can cause issues with installation because the conductors might be too large to manipulate. The NEC provides tables that list the ampacity of various types of cables based on their size, insulation, and installation conditions. These tables can be used to determine the correct cable size for a particular application. In addition to the NEC, many local jurisdictions have their own electrical codes that must be followed. These codes may be more stringent than the NEC, so it's essential to be familiar with the local requirements before starting any electrical work. The local electrical inspector can provide information on the applicable codes and can also inspect your work to ensure that it meets all requirements. When installing underground cables, it's also important to consider the environmental conditions. For example, if the cable is located in a wet or corrosive environment, it may be necessary to use a special type of cable that is designed to withstand these conditions. Similarly, if the cable is located in an area that is subject to extreme temperatures, it may be necessary to use a cable that is rated for high or low temperatures. The type of insulation used on the cable is also important. Some types of insulation are more resistant to moisture, chemicals, and other environmental factors than others. The NEC specifies the types of insulation that are permitted for various applications. Common types of cable insulation include thermoplastic high heat resistant nylon coated, cross-linked polyethylene, and rubber. Each type has unique characteristics, so it's important to choose the one that is best suited for the application. Thermoplastic high heat resistant nylon coated, or THHN, is a common type of insulation that is used for general purpose wiring. It is relatively inexpensive and is resistant to moisture and oil. Cross-linked polyethylene, or XLP, is a more durable type of insulation that is used for high voltage applications. It is resistant to heat, chemicals, and abrasion. Rubber is a flexible type of insulation that is used for portable cords and cables. It is resistant to moisture and abrasion. In conclusion, the minimum depth for burying electrical cable from the transformer to the service panel in a residential setting is generally 18 inches, but it's essential to consult the local electrical codes and regulations to ensure compliance with all applicable standards. Following proper installation procedures, including grounding, bonding, and cable selection, is crucial for electrical safety and for ensuring the long-term reliability of the electrical system. Remember to call local utilities before digging. Always hire a qualified electrician if you are not comfortable with the electrical work required.